Hello, my name is Andrew Rubenstahl, and I'm a mechanical engineering technology student here at Alfred State College. This is my senior project proposal presentation for my idea for the automated long jump pit. My motivation for this project was I've been doing track and field for about 9 years. I started when I was in middle school in 7th grade. Since then, I've been doing the long jump, high jump, pole vault, and some multi-events, including the heptathlon and the decathlon, which is 7 events and 10 events, respectively. All these years around track and field have given me a unique insight into some of the sports problems, especially the engineering problems, now that I'm a student of engineering. So, quick overview of what this presentation is going to be about and what my project is about. I'm going to be designing a new type of long jump / triple jump pit that will use an integrated fluidized air bed that will eliminate the need to rake the pit. So athletes in the sport jump into the sand, and after each jump, the pit, which is where the sand is held, needs to be leveled and raked after each jump. I believe this process usually takes like about 2 to 4 people to accomplish, and can take anywhere between 15 and 30 seconds to do. And with anywhere between 6 and 30 jumpers in a meet, or even just one flight of the meet, this can be very time consuming. So my solution is we can blast air up into the sand from the bottom, and this will both aerate the sand, making it for a more cushioned landing for the jumpers, as well as level the sand perfectly. So for those of you that might not be familiar with the sport of long jump, I just have a quick clip of some jumps so you can see what the sport's all about. So these jumpers are IAAF Diamond League athletes. They're some of the best athletes in the world at this sport.
Oh, that's big, that's huge. That is a super jump.
So as you can see here in the replay, when the jumper lands, quite a bit of sand is displaced from his feet in the landing, creating a hole, and even when he stands up, more footsteps are created that can make even more holes that need to be raked out, and the pit needs to be re-leveled. So furthermore into the problem, the sand in the long jump pit provides a soft landing for the athletes to prevent injuries. Unpacked or packed and uneven sand can lead to ankle injuries, knee injuries, all sorts of stuff, bruises. It's not a fun time. Been there. So the problem is that after each jump, it's uneven and needs to be raked flat again. And this requires, like I said before, a team of people to do by hand with rakes. And this is very time consuming and can also lead to an irregular surface of the sand. And an irregular surface, maybe it's slanted this way or that way, whatever. This can cause advantages or disadvantages for each athlete depending on human error. You know, if the sand's sloping away from you, that athlete will have an advantage, and slants jumping towards you, the athlete's essentially jumping uphill, which gives a disadvantage and will result in a lower mark of distance. So my solution to this problem is to design an automated system that accomplishes the same goals as raking does. So this would result in more accurate measurements and lots of time saved. The way we do this, I believe, is using a fluidized air bed. A fluidized bed is the state that describes the two-phase mixture of a solid material, in this case sand, and a fluid, in this case air. It's similar to an air hockey table, the way pressurized air is pumped up through tiny holes beneath the surface. In this case, beneath the surface of the sand. This will give the sand fluid-like properties. And when the flow of air, which is fluidizing the sand, is shut off, the sand will settle back to its original state and will be perfectly level and flat all the way across. This fluidized bed technology is also used in grain silos and powder coat painting to evenly move grain through silos and to evenly paint the surface of a object that you're trying to paint. So some contributions that I had to this idea, I was inspired by a project that was done by a YouTuber named Mark Rober, who's a former engineer himself. And he used this concept of fluidized air to turn a whole hot tub into a fluidized airbed, which is pretty cool. In this video, he also created a small-scale fluidized bed to demonstrate the concept that he was using. When I watched the video, what I noticed is that when he shut the sand off, and the sand was no longer fluid and bubbling and bouncing all over the place, the surface was very flat and level. Another YouTube page that I got inspired from is called King of Random, and they used Mark Rober's concept to made a video on how to make a detailed tutorial on how to make a fluidized airbed yourself. So the existing technology that works with fluidized beds includes many industry applications, including, like I mentioned, moving grain through silos, but also drying grain or other materials. Powder coat painting, for removing dissolved waste from recirculating aquaculture systems, as well as the combustion of waste and or fuel. By blasting the fuel or waste up into the air, it can be, there's more surface area, more oxygen gets to it, it can be ignited much more easily. The same concept is also used to aerate pools for divers. So when they're practicing their jumps, if they mess up and do a big old belly flop, the bubbles release the surface tension that would normally be there on flat water. So the divers have a more cushioned landing. So the design concept. The device will be a model prototype of a larger design that could be applied to a full-size long jump pit. I'd like to create a small-scale model of a long jump pit with a runway. The model will be similar to the one created on the King of Random and Mark Rober channels on YouTube, and we'll use a PVC pipe lattice on the bottom of a plastic container, roughly about 40 quarts in size. And it'll have 2 air inlets on the bottom. Now, drilled into the PVC lattice will be small, about 1 millimeter holes that will point at 90-degree angles from each other, downwards into the container. This allows for the sand to not get clogged into the holes. If the holes were pointing upward, the sand would just fall back down into the PVC piping and fill it up. We don't want that. So the 2 inlets of the piping would be connected to a small 110 volt, 3 to 5 gallon air compressor with a globe valve and a pressure gauge in series, so we can control the flow and see what the pressure is and determine the best, the ideal pressure and stuff like that, and do other experimentation to figure out how this system would work best for our application. So here are some examples of the design. As you can see here in these 3 pictures, this is the PVC lattice that I was talking about with the 2 air inlets. These 2 air inlets go to in my case, will be a globe valve and a pressure gauge, not shown in this picture. And then in the PVC lattice, underneath it are a bunch of tiny holes spaced about 1 to 2 inches apart along the entire lattice, covering as much surface area of the bottom as possible. In this picture, you can see what it looks like a finished product. The ping pong balls are almost floating in the sand and bouncing up as if they were in a liquid. And that's the goal we're trying to get to. So the steps to accomplish this project, I'll begin with SolidWorks designs of the fluidized bed itself with the PVC lattice. A scale model of a long jump pit that will incorporate the fluidized bed that I've made, and a SolidWorks design of the compressed air system I'll use to power the system and blow air up into the sand. The implementation will be a working scale prototype of the fluidized bed and a scale model replica, as I mentioned. Testing will involve determining the ideal sand type, ideal air pressure, and the size and configuration of the outlet holes, the small outlet holes, as I mentioned. So the sand will be evenly blown up throughout the container and will settle down as level as possible and as flat as possible, of course. Some potential applications that I mentioned before, in this case, the leveling, flattening, and softening of a sand long jump pit. Powder coat painting, again, and also could be used to sort different sized gravel or sand, as the heavier and larger particles will fall to the bottom and the lighter, more fine particles will be distributed in the top. This is the Gantt chart showing the schedule of my project, starting up here in September with the proposal, which I've already completed, and would end down here with the final presentation in May, I believe. This is a quick list of materials and equipment that I may need to complete this project. These were all the things that I could think of that I may need, but more may need to be added as the project goes on. It includes PVC piping and fitting, PVC cement, the large bin I was talking about, plywood and 2x4s, the 3 to 5 gallon air compressor, which may contribute to most of the price of the project, actually. A 5 gallon supplemental tank could also be used to, along with the air compressor, to extend the time that we can allow the system to run for. We'll be using a fine sand. In my research, I've found that most people that have done this or something similar to this have used, let's say, fine sands work best, or even fine glass bead, which is used in sandblasting, is a very good material to use. And here are my references for research for my project. And that is all. Thank you.